Okay, so this time I will actually start from a small template. Basically, I already created the make files, let's call them. I wanted to use Webpack this time to compile all the code together, right? So we are gonna use the AStar implementation from last time and create some new JavaScript code that will load the WASM module and then display it in the browser and allow the user to um, create mazes, I guess, for the algorithm to solve. So in the Webpack config, it's pretty basic. I also created this Clang plugin to run the Clang compiler on the file that we will create. To be honest, I'm not really sure how to work with it. I just tried out hooks until it worked, but it's easier than reading the docs. And we are gonna build in the dist folder, and we are gonna start from an index.html file. It's gonna be like empty, but uh, still need a starting point. We'll put our code in this src astar.c file. Basically, we'll just copy paste the implementation from last time, from the examples of data structures, and we'll have to adapt it to work with WASM. Basically, we'll have to fix all the compilation errors from here because we are no longer allowing stdlib and all the good stuff that comes with it. So we need to implement those things either on our own or not use them. It's easier to not use them, I guess. This thing I have no idea what it's for, but I had it in an older project, so I installed it. Then I guess for Webpack to find the TypeScript files. Oh yeah, also we are gonna use TypeScript because it's better than JavaScript. I mean it's still bad, but a bit better. And then yeah, so if you remember, we were using HTTP server when we were testing the development from Python, but I thought it's easier to just have the JavaScript version. So this is the same thing, but like here we specify the directory and the port, so it looks exactly the same. And yeah, that's everything in the Webpack. Then for tsconfig, I just took it from the docs. Pretty the same thing, but I changed it because I mean, who like trailing comma? I see everyone uses trailing comma, but really no semis and single quotes. Like these were the other way around, and two spaces. Who uses that, right? Anyway, going to the next thing, it's the package JSON. So yeah, as I said, Webpack, the dev server, to no longer use the Python one, and this is to, I don't know, the plugin for HTML, I guess, prettier to format our code, and TS loader to be able to compile the TypeScript that we have. And yeah, some basic scripts, build, serve, runs the Webpack, format just to prettify the code, format the code, and test. We don't test. We just yeah. I mean, I don't see the point. Maybe, but I'll do it on my own. I guess the tests are not interesting to watch. I see that. And yeah, so this is the index. As I said, empty. I put only this thing. I think this is to make the web page look nice even on mobile devices. So yeah. Then for the C code, as I said, I copied the ds.h library that we made. yeah, in I think 2 days ago. Well, it's not complete. It only has the priority queue, but it's a starting point. We can add more if we need. Then the astar.c file, which we have to write. I mean, this is, I was just playing around with the code, trying to see if it works. And in the TypeScript file, here we're gonna need to load the module, the WASM module. I just set up the memory, and yeah, we'll have to set up everything else. So let's see, let's start. So as usual, we start with a copy paste from the ds.h project. So let's go into AStar. And I mean, let's copy paste everything and we see what we delete. So first of all, we don't need a main function, that's obvious. We don't need a world print because we don't work with the terminal. We also won't need to read the words from a file because we don't. And we also don't need this thing. I mean, I put a comment there, but no. So this one is in include actually. Okay, perfect. So now we have like all the code that we need to run the show, I guess. So it's basically just the AStar function, right? So now we'll have to see how we can interface this file with the JavaScript world. So let's create an astar.h file. This will be our interface, let's call it. So if not defined astar.h, we define it, and then, well, and if the definition. Okay, so for this thing, astar.h, no, astar.c. So I was thinking to make a little function where we actually call AStar, because here we pass in a world, position, another position, we get back the position array, which is just more positions. So my idea would be, what if we have another function similar to AStar? We call it path find, but like instead of a world, we give it position array, and we give it the obstacles. So obstacles, right? So it's just easier to imagine. We give the pathfind function a list of points where are obstacles, the start point, the end point, and we get back the list of points that we have to walk from start to end. And yeah, we also need width and height, just for the memes, I guess. So let's take this thing, let's put it here, right? So what's nice is that we don't even need to define the structures. How does it work anyway? Let's then include slash AStar. Let's include the AStar thing, and yeah, I guess let's put these structures then in a, well, at least let's define them at least, right? Like at least define the structures, so this works. So here what we need to do, oh wow, I mean I deleted the main function, but it was similar to main, which is funny. We need to create a world, so let's copy paste this, right? Then we need to init the world. Here in this we read it from a file, but in our case we just init it, right? Just init it. We don't print. We'll need a position array like this. Well, we already have it. So obstacles. So yeah, we actually need to go through all the obstacles and just set it. Let's see. We're gonna have a default, like it should be similar, really similar to this. So int result is 0. Let's return the result, and here let's use our return refer. But yeah, whatever. So we set the thing, and now we just have to call to AStar. Well, AStar, I think it returns 1 when it finds the, so let's maybe change it to return, well no, I mean it doesn't make sense. It returns 1 when it finds the path, like it's a boolean. So yeah, basically instead of reading from a file, we initialize and then we set all the obstacles as a 1, right? And then we call AStar, and then we free the world and return the result, which is just the error code. And P will be set to have the let's say the path, right? So yeah, basically we export this, so we should be able to say find, I mean we can take all the symbols, but the important one is just path find. We are gonna need to allocate some stuff in the WASM memory and then call to path find. So that shouldn't be really hard. So let's see. Let's do npm run build to get like the errors. So as I said, we won't be able to use stdio or stdlib. So let's see. We can't use any of these limits. I'm curious to see. Don't know how to look into it, but it's I mean I think it's just like some define, so I wouldn't know how it's part of standard lib, so let's leave it. Okay, so if you remember from our implementation, we have some small things, like for example, no stdlib. So we won't use stdlib, and no stdio. So we don't use IO stuff, right? So let's define no std. Well, it's a ds no stdio. And then, yeah. So basically, now we can see the errors in the editor. That's nice. When we define this no stdlib, actually, we have to define all the dsmalloc and stuff, right? We need to define these. And let's call them AStar malloc. Let's call this one AStar realloc, AStar free, and AStar exit. Now let's see. Here we need to do AStar malloc. Right, we need to do AStar malloc. Here we need to do AStar free. Abs. It's in stdlib. We'll implement that. It's pretty easy. I mean, we'll just convert the code or something. This one is just AStar malloc, AStar free. Okay, these are fine for now. We just need to define our functions. Right, so let's just go with this for now. Here we need to also use our own implementation of free, and everything else works. So let's take these, go into astar.h, and let's put them here. So this will be void pointer, and I think this should get an int for the size. This should also be void pointer, int old size and new size. Oh yeah, in our code, realloc should also use the old size. You'll see why. Free is just free. We want free any memory, like for free. I mean, it's too complicated to do, but you get the point. Then this will be a void, and we'll get the int as a code. Well, let's see malloc. Do we have it? It uses unsigned int. I mean, let's use unsigned then. Unsigned. Okay. And here we also use unsigned. So we have. I'm curious. Exit. What does it? Anyway, we have to. I wanted to see what the argument to exit was, if it's unsigned or not. But this is the syscall. Let's see something else. Yeah, it's just an int. Anyway, so we need to define these functions, but it would be really hard to do it in C. So let's export them as undefined, and we'll implement them in the JavaScript code to work easier with the memory, right? And let's see what other errors we have. So for abs, we'll see that, and pretty much, yeah, that's it. Just this one. So let's say here int abs. My abs. Anyway, I mean, we can also leave it like this. It is what it is. We implemented it. We don't care. So if now we try to run build, I think the WASM module should compile. So let's remove build, or it's this, yeah. And now let's npm run build. So I think it should compile everything. Yeah. So if we check out this, we should see the WASM module. But if we are going to try to run this thing, so let's serve it, what is going to happen is that this is going to complain that we don't have these functions defined, right? If you remember from last time, so the C code, now it works. We no longer need to look into the C code, basically. So now we're going to switch to TypeScript. Let's just copy this. So if you remember from last time, we had to define into env some functions because we couldn't run the program without defining these. So let's just copy paste. This is gonna be a function, takes in the size and does something with it. Well, it's gonna be a number and returns a number. That's how you say it. Well, let's was it? No, that's in Rust. Oh, it works. Okay, let's do AStar realloc. We give it a pointer. We give it old size and new size. Doesn't do anything for now. Then we have, well, it tried. We give it AStar free and AStar exit. Okay, so the question is, right, how are we gonna alloc stuff or realloc stuff? Like, we need some type of dictionary that will hold the addresses that we allocated, or some array or something. And for that, let's build an allocator class, right? So we are gonna have class allocator. Okay, and this class will have, let's see, is that memory? So the memory, I've tested it and it works to have uint data array. And this dot, let's call it offset, why not? Wait, it's like this. And the offset is basically, at first it will be the base pointer, or I mean the what was it, the heap base, right? It will be the heap base, but as we continue to allocate, it will increase. And if you have already guessed, we won't free any memory, we'll just continue to grow our array like crazy people. So I mean, it's JavaScript, so what would you expect? So yeah, and what we want to do here is let allocator, we initialize our allocator, and now we can actually initialize it, right? So here, as always, I've already used to copilot being useless, so we have to do this. And here we need to actually instance exports, we need to do the heap base, and we need to say as WebAssembly dot global, that's it was dot value. And let's close our allocator. So yeah, basically the allocator, right? So now let's have a malloc, and how malloc works is we give it a size, we have to return the current offset and just increase the offset with size. Realloc, we have basically what we have to do is to malloc a new pointer of size new size, and then we have to copy the memory from the old pointer, which is ptr, and we have to copy all size bytes to the new pointer, and then we return the new pointer. And as you see, we don't free will be like console log chats don't free. Okay, so this is basically the allocator class, right? And here we just return allocator malloc. How is it hard to just say, okay, here free? I mean, if you want to do free, you just have to change to switch up the allocator, right? Like, you know, we could create an interface for allocator, and then this would be the naive allocator and do dependency injection, but pretty much the thing. And for exit, we just say exit code. Usually I like to do it like this. So now we defined all of these functions, right, that we had to define in here. So if we rerun this, it actually gives us no errors, which is pretty nice. Okay, so I know I said we won't look in the C code anymore, but we actually have to a little bit. So here we give the obstacles, the width. I wanted to see just how we might need some functions like from, what was it? It was in Tetris bits. Right, like here we have this cool decode function. which we can use on the memory to get like data structures and stuff. And we might use it to also write into the memory data structures. So let's create a class for position. So position basically, okay, let's go. Position was just struct position, just x and y, so 2 4 bytes. To be honest, I think I would rather have it in here, so it looks like, oh, you actually intend to say like 4 bytes, and this one is also 4 bytes. So like the size of position, you would expect it to be 8 bytes, right? And we also have structure position array. Let's also take this one and put it here. So this one is 4 bytes because it's a pointer, of course. This is also 4 bytes, and this is 4 bytes. So, oops. Yeah, let's just format. So now we see these structures, right? That's pretty much all we need to implement the stuff. So let's go back into index TypeScript, and let's see. So this one is this. Let's do it under the allocator. So we have class position. Okay, we are gonna have x and y as the numbers, right? And the same how we did here. Let's copy this thing just to have it. So we need a decode function. I don't remember. Can you have type? What am I doing? Type script class static function. Can you have static? No. I guess so, yeah, static. So this should be a static function. So this will be an uint8 array, and this will be a number, and it should give us a position. Yeah, so we have decode, gets the memory, the pointer where we want to decode, and it should return the position. So yeah, that's not good. I saw a cool way to do it, so let's see. X equals, we make a data view. Basically this is what I saw, right? You use data view, we give it the buffer, so data view takes in like a buffer. It takes an offset, which is pointer, our pointer, and it takes how many bytes, I think, to put inside this data view. So 4 bytes, right, for an int, and then we convert it to int32, and then we also get y, and we just return a new position. Pretty cool, right? And then we have an encode which does the reverse. We create a data view from the buffer, and we set the int I mean, I don't understand why you wouldn't put the offset here. It's more cool. Anyway, I mean, it's the same thing, right? You can put this here, yeah, whatever. Like me personally, I would say PTR 4. Like this looks better because it's the same as here. So this is how we decode or encode the position. Okay. So next, let's do the position array. So class position array. We are gonna have items. So it's gonna be positions. We are gonna have count and capacity. So constructor is like whatever. Static decode. We take in the same arguments. Okay. So items ptr is gonna be the first thing. Then let count. So if we look here, the next thing is count. We take the count and then the capacity, right? So we have everything. Now we need to get all the positions from the view. So let's create an empty list. And I think now we have to iterate over the count. And then we just have to decode, use our position decode, yeah. And the pointer will increase by 8 bytes because the size of position is 8. 4 plus 4. Quick maths. Was it 2 plus 2? Yeah. Anyway, basically this is the decode. And for encode, let's see if Copilot does it. So what the hell is even that? Well, for encode and stuff, I think we might need to use the allocator. Like here we set the stuff, but we might also need to allocate. So let's see. So let's also maybe instead of this, let's see allocator, right? So first we need creator. and maybe we should return the pointer. Maybe let view equals the memory. Oops. Yeah, like maybe this makes more sense. Like how I did it before, you think you allocate outside and then you call encode. But I think it makes more sense to alloc inside of encode and just return the pointer. I think maybe it makes more sense. So here decode whatever, and here let's say allocator, and it returns number. So we do this, we have to allocate 12 bytes for the structure itself, for this pointer, like for this number and this other number, and we also need to allocate 8 size of position times count. Well, times capacity, it would make more sense. Yeah, right, it makes more sense to allocate capacity, not count. Capacity. Because if we create an empty position array, count will be 0, but we want to be able to add into it with capacity. So capacity should be the size of the malloc. So here, well, this is why having the allocation outside made sense though. Yeah. Like for this one it makes sense to be inside, but okay, let's have another function encode that takes in the view and the size. Can we why can't we have overload? TypeScript class overload function. Can't we do wait, what? Anyway, you know what? Okay, so this should be maybe called alloc, and this should be encode. So here we can say this encode. Okay, so this is gonna be alloc, right? And it encodes stuff because we already allocated the memory, so we no longer need to allocate the structures. So yeah. Yeah, okay, fine, whatever. So let's put this on here. So then I would like to also have encode for this one. let's see if it can do it. Yeah, so this part should be this encode. Okay, fine, whatever. Now we have the position structure and the position array structure, right? We can allocate it, we can set it, whatever. Alright, so now if we look at our pathfind, let's take it in here. Let's say something like this. So we can create an array of positions then, and if we say allocate should initialize, it should put them, right? So let's create these things. So let's do let obstacles is a new position array, and how was our example if we go back to DS examples world. Yeah, it would be nice to parse this string. So let's make a function, a quick function parse, or should it be parse obstacles input string. So that should create let obstacles should be a position array, right? We split the line, but why? To get the width and height, I guess. Right? Yeah, something like this. And then we just have our obstacles. But what would be nice is if we can have a tuple to also give us the width and the height. So this is the width, this is the height. Maybe let's call it parse world, right? And now let's have a const world. It's gonna be, can we have JavaScript multi-line string? Let's see how we can have a multi-line string. I already scrolled to the half of this page and still no. Only like what's almost the bottom. Like, dude, just it's so annoying when you have to read through an entire article just for okay, so that means we can take this thing, say parse world. Let's put it like this. So as I said, this returns the position array. So let obstacles with height equals to this thing. So you have the obstacles, the width, the height. We just need a start and an end. So let's say let's start and end should be width -1, height -1. And finally, let's create let's create the results. So let path is a new position array. It's gonna be like empty. Oh, it should work with it empty, right? Yeah, I think it should. Why not? Okay, so now let's put these pointers into memory. So we're gonna need, it's so annoying that, oh, yeah, wait, that thing would be bad. So let's put it somewhere here. So let's put obstacles into memory. Let's put start pointer, end pointer, and path. So these are all the things. Okay, so we need to define the type for our function. So let path find equals. I don't get it why when I like somewhere let's just give up on this thing. Like see when I anyway, so let's define the function type for our pathfind. So type pathfind function. It should be, yeah, something like this, I think. The obstacles with height, start, end path. Okay. So as pathfind function, and now we can actually call it pathfind. Okay, we console log the result. So let's see if we just run this thing, we get a 0, which is good, right? Because it was the error code. So now let's say path equals, let's decode it, and let's see. Oh, I wonder why it's in reverse though. I wonder why it's in reverse. That's a bit strange. But see, it worked. We got the path, although it's in reverse. Why would it be reversed? That's a good question. let's just print console.log path. Like let's just see it. So the capacity, it was realloced, right? It's weird. So maybe did I just print it in reverse here? Oh yeah, you have to do it in reverse. Oh yeah, it makes sense because the first item will be the goal. Yeah. So here we need to say path count. Yeah. So now if we refresh, we just get the path. That's really cool, right? So yeah, what we actually need to do is to actually create a new UI now. So how are we gonna do that? We're gonna create a canvas, right? And then we need to allow clicking on it. That's that can be a bit challenging. So yeah, let's see. Let's see. So maybe create a commit for this part because I was thinking to delete this. Yeah, let's see here, initial commit. Well, I mean it's initial commit basically. This is the first commit on the video. So I mean maybe even do something like allocator.ts, right? Put the allocator here just to have more space. Well, no, we still have to test that it works because I'll be honest, default exports, export default was, what was it? Yeah. So now we need to say import allocator from allocator. Is that enough? Interesting, that's enough. So we can also take positions and maybe even the type. And we can say that these are like AStar H, basically. AStar so we need to import allocator. Let's export these things, right? Like these are the data. Like if you look at astar.h and you look at this file, they are the same thing. I mean, except the top here. But I mean, you see, right? Okay. So now you have to import, and it's also the pathfind function. Right now we have everything. So if we Yeah, I mean, still works. Okay, perfect. So now the plan is delete parse world. We no longer need to do the parsing or this thing. Let's say we are gonna have the width and the height as constants. So const width is gonna be 10. Const height is gonna be 10. Okay. We are gonna just say that start and end are gonna be like this. So we just need to create obstacles now. So let's say then const cell width is gonna be 10, I guess, or something. And let's say create canvas maybe, right? We need to create a canvas where the user can see all the cells. So function create should it be create grid? Well, that's cool because we can put random, but no, we actually just need to create the grid where the user can draw stuff. So let's say let canvas equals document dot create element canvas. Let's set, can we do this thing? Let's also maybe create let div let root equals document dot create element div. Can we say like just for the memes? And then we append the root. Here we should append the canvas like this. Oh, boolean. Well, it's a void. Okay, we have to see then. Okay, let's comment this thing out. This is gonna be like you put all the obstacles on the grid, and then you press like a button, and when you press that button, it runs this stuff. So that's what I'm thinking. So maybe we can pull this thing out in a separate function, like pet find wrapper or something. But yeah, and it returns. Yeah, anyway, so let's do it now actually. And yeah, for now it will just do path find. Oh, it can actually be path find. So obstacles, it should be position array, and it should return a position array, and it's just like this. Return path. well, it also wants the allocator, but the allocator is actually defined here. Right. I mean, we can also have like a class, but for now it's fine, I think. So let's continue with our thing. Can we maybe draw a grid? Create world. Yeah. Can we draw a grid on the canvas? Can we do something like that? Let's see. So we need to call this create world. Oh, that's something. Let's make these a bit larger, like 50. Okay, I don't like that it has duplicates or what? So it's and then it needs to do this. But see, it's not that good. So I think it shouldn't. So move line, good position I, but it also needs to do another one for the end, right? Like for the last thing. Okay, I'm pretty sure you can do this in a much better way. Yeah, anyway, let's also do the last one for this. So now we would have a grid. This would be too large. Okay, let's leave it at 32 or something. Or 50. Let's leave it at 50. Okay, and now the idea is to let the user click right on these cells. So this is the drawing. Let's pull this thing out in a function. So function draw grid. I don't know what arguments it will take, but it needs the canvas, width, height, and maybe even cell width. So let's say here draw grid. Okay, still fine. Just to not have to look at it every time. So the next thing is on click event for canvas get the grid, the cell that was clicked. Can we do something like this? Okay, so we have the click event. And yeah, how we get the x and y of the grid is just by dividing the x with the cell width. So if we click this, it should be 0, 0, 1, 0, and this should be 9, 9. Perfect. This is exactly what we needed. So let's strip this thing. Okay, so I'm really thinking a class would have made sense here. But we are gonna need a global variable to work with this. So yeah, let's try to create a class. Let's put it here. So class world. So this should have width, height, cell size, and let's say we should also have obstacles, which is going to be the position array. We initialize it as empty. Well, I think it makes more sense to have an actual position array. Because we don't have the implementation from C, like those are just wrappers to be able to encode and decode the memory. They are not really implementation, so this is actually the position array. Right, so now let's take this thing, the draw grid function. Let's put it inside of this. So we won't need like we can say, wow, this is really bad. So let's also take create world. Let's close this, and now we can go to the errors. So this is this width, we have cell size. I mean, see, what Copilot is good for is just fixing these kind of errors, because it's I mean, to be honest, it's faster than me having to do it. So yeah. Okay, create world, I think should be calling the constructor. Yeah, well, I think it should be calling the constructor. This create world. Okay. So now we can say this dot obstacles and create a new position for our stuff. But this is interesting. We want to be able to toggle them. So maybe we should have a matrix. Maybe it's easier to have like a visited matrix, you know. The thing that I'm thinking of should be map like this. Can't you do like no, it should be like this. We create a new array, and then for each line we create another array, fill it with false. So here we toggle the thing. Draw the grid, and can we actually render world? This might be needed in the render. So this just creates everything. Let's put canvas into a thing here. So canvas, and let's say this canvas equals, let's say this thing creates a canvas. So HTML and return the canvas. So now we have the canvas. We can draw the grid, right? We can also get a context. I don't get it. I want it to just clear. Can't I just clear rect? Okay, and here we should draw something on top. So I think this is everything. So let's see, create a new world, and now we can reuse the thing that I made in Tetris bits, like that for loop or whatever it's called, the game loop. So we create a function called game loop. Let's create a function called game loop. Here we request animation frame. Let's just copy paste this and see what we need from here. I like doing it like this. So now FPS interval is like, oh, FPS. Let's put it here, the FPS thing. Let's put it higher up. And what is FPS interval? It's here. FPS interval is this, and also then. So let's define these things, FPS interval, and then. So we know that in here we should do the rendering. So world render world. Oh no. Well, I mean, this function is not called anywhere, so why wait, what? Why can't I see any errors? Yeah, let's stop that. So we have only one error because it's on line 96, I think. No, that's because it compiles it on line 60. This map Y. You're saying maybe. Okay, let's. I mean, it's not even going there. So what? Okay, you know what? Let's just that's so interesting. You literally have to feel it to be able to map it. It's so crazy. Anyway, so now if we click, it creates obstacles. That's so cool, I guess. So let's take this function and put it inside the world. So basically we have the pathfind function in here. Oh, so it takes in obstacles. I mean, we will create obstacles, and I think it shouldn't return anything for now. So, and it's gonna be this width, this height. Okay, we need to create the obstacles. So obstacles let's say positions, and then for this thing we create all the positions, and then we can create obstacles. Like, was it really that hard? I have no idea. And here let's just console log it to see it. Just the points like that. Wait, what? Oh, we don't need the result. Yeah, we don't need it. So, well, actually, let's return result just to have cool stuff. So now we just need a button to run the pathfind. Let's see, when we create all the stuff, let's say let run button, create a button, and when we click it we do pathfind. we also need to append. I mean, it looks like trash, but let's see. It got something. Now the idea is to draw it. So let's also keep. How can we do that nicely? Let's have a path, which is going to be a list of positions. So basically, here in pathfind, we just have to say this. No, this dot path equals path dot items. We just take the items. So yeah, and in a render world, we have to check if the path is there. What is it trying to do? I mean, it looks cool, but I was thinking just to. I mean, it looks better than I expected. Oh. Okay, we need to figure out why that happened, but like you cannot run it after you already ran it once. Okay, I have another idea. So let's go into allocator. Let's have a reset function. Reset. Well, maybe we can just keep the offset, because I was thinking to just. Okay, so let's call it base. This dot base. So base doesn't change, and here we just set it back to base. Right. So after we do the path find, I would just reset it. Allocator reset or something. So okay. Not really. I think we should reset it before pathfind. So was it like a problem with? Yeah, I mean, maybe it was a problem with that. So yeah, I actually found the issue. If I set the memory to 0, like the memory that was allocated to 0, then it worked. It means that somewhere in the AStar code, we probably do malloc and expect that the values inside there to be 0. So like that's an issue. That's why I usually prefer to use calloc, because that also clears the memory. It sets it to 0. And when you use malloc, it's just the random data that's already there. So maybe what we actually need to do is search in the AStar code, in the C code, see where we used mallocs, and also set the memory to 0, like use memset or something. But yeah, it's just easier to do this. We just reset the memory to 0, and it is what it is. We just try this. So like if we break it and we, yeah, then it works again. So let's do a more complicated maze. Let's have it, yeah, like it can figure stuff out. Okay, and yeah, like as you can see, it can find the paths through the maze pretty easily. Yeah, the only thing is that we have the starting point in the, I mean, you know, it's just the easiest way to do it. So yeah, it's an implementation of AStar that shows you the path that it found. And yeah, we actually used WASM to run the algorithm. So basically we run the path find from C code, and in JavaScript we just have to allocate all the data structures on the WASM memory. We allocate them here, and then we just call to the path find function. So maybe one other thing would be, you know, instead of accessing W, the global variable, to send the path find function in here. But yeah, I mean, I'll do that by myself. So yeah, we actually have the path find function, and I guess this was the point of this small project that I think took like 3 days. Yeah. So yeah, I guess I'll make it possible to run it from the GitHub pages, as I did with the Tetris. So if yeah, you missed the Tetris videos, you can watch them. And yeah, basically you'll be able to play with the project from the browser, like for Tetris. So yeah, I leave everything in the description, and yeah, see you next time.